Good morning, students. So in the last class, we discussed about the atomic number and also the mass number. Okay. So in the today's class, I will tell what is the atomic number, how the element is represented, how to calculate the number of protons, number of neutrons and electrons in the respective atoms. Okay. So listen. First, I write if this is the element. If this is the element, then this is represented by ZA. Okay. So what is this Z? Z means atomic number. Okay. What is this A? A means mass number. Okay. So then, what is that atomic number, students? Atomic number means our atomic number is equal to number of protons. So, number of protons is equal to number of electrons. Okay. Next, mass number A is equal to number of protons plus number of neutrons. So students, if you want to calculate the number of protons, I told you protons is denoted by P, electrons is by E, neutrons is by N. If you want to calculate number of neutrons, then this is taken as what? A minus number of protons. Because atomic mass is the sum of what? And right here. So atomic mass is equal to number of neutrons plus number of protons. We want this means N is equal to A minus P. If atomic mass is subtracted by atomic number, then we will get what? Number of neutrons. This is all about the atomic mass, atomic number, mass number. So how to calculate this atomic mass number? You remember this thing. So I write some of the elements here, students. Right, one by one. So for example, I'll go with one hydrogen, one. Okay, so compare this with this. Here Z is 1, A is also 1. Then, so students, number of proton is equal to 1. So number of electron also equal to 1. So number of neutron means number of neutron. Are I right? Directly I will write proton 1, electron 1, neutron, that is atomic mass minus atomic number, that is 0. Neutron is 0. I hope you understood. This is Z, this is A. A is equal to what? Number of proton is equal to number of electron. So this number of neutron means here I wrote atomic mass minus number of protons. Okay. Atomic mass is 1 minus 1, that is 0. If you want to check it for He2O4, okay, so this is P. So number of proton is 2, then the number of electron is also equal to what? 2. The number of neutron is 4 minus 2, that is equal to 2. 4 minus 2, that's equal to what? 2. Okay. So next, Em. Next, carbon. 6, 12. So here, the number of protons are 6, number of electrons are 6, number of neutrons are 12 minus 6, that is equal to 6. Okay. If you think argon, this is 18, this is 40. So your number of proton is 18, number of electron is also 18, number of neutron is 40 minus 18, that is equal to 22. Okay, similarly you take sodium 11, 23. Here the atomic number third, that is proton is 11, electron also 11, neutron is 23 minus 11, that is 12. So this shows what students? Number of proton is equal to number of electrons. So how many protons are there? That much of electrons are also there. Then neutron is the atomic mass minus the number of proton, or atomic mass minus atomic number, that gives the number of neutrons. So this is what this we can study in your neutral molecules. Okay, this we are going to study in neutral molecules. There is no plus charge like Cl minus, Na plus. It is not like that. Okay, here they are neutral charges, means with the zero charge. Okay, this is all about the atomic number, mass number, and then how to calculate the number of neutrons. Okay, so next one, students, we will discuss with atomic mass, okay, molecular mass, and also equivalent mass. Okay, so first one is atomic mass. Okay, so atomic mass means it is the ratio of average mass of one atom to the mass of 1 by 12 of carbon 12 isotope. So students, here atomic mass is equal to average mass of an atom divided by mass of 1 by 12 of C12 isotope. So this is the definition, this is the formula. So what did this mean, students? If atomic mass of oxygen is 16, what it shows? The mass of oxygen, especially the atomic mass of oxygen, is 16 times of mass of C12 isotope. This is the reason. The atomic mass of oxygen is 16 means the atomic mass of oxygen is 16 times of mass of C12 isotope. Okay. So next. Second one is molecular mass. So what is molecular mass? I'll say it is the ratio of average mass of one molecule to the mass of carbon 12 isotope. mass of 1 by 12 carbon isotope. Okay, you want to write the formula. Molecular mass is equal to average mass of a molecule divided by what is mass of 1 by 12 C12 isotope. So here what it says, molecular mass of oxygen is 32. What it means, students? It means the mass of or the molecular mass of oxygen is 32 times of mass of 1 by 12 C12 isotope. Mass of C12 isotope. So this is molecular mass. So then another one is there, that is equivalent mass. What it is? Third one, that is equivalent mass. So what is the equivalent mass, students? So equivalent mass means it is a mass in which the mass of an atom or it is the mass of an element defined as when it combines or displaces. Okay, the mass of the element is defined as the mass of the element combines the mass of the element combines or displaces 1.008 gram of hydrogen or 16 gram of oxygen or 35.5 gram of chlorine is called as what? Equivalent mass of the element. If any equivalent mass of the element is defined as the mass of the element combined or displaced 1.008 gram of hydrogen, 16 gram of oxygen or 35.5 gram of chlorine, that is called as the equivalent mass of the respective element. For example, equivalent mass of magnesium is 12. What it means, students? The equivalent mass of magnesium is 12 means, so the magnesium displaces 1.008 gram of hydrogen when it reacts with HCl. Yes. So this is the answer. Mg displaces when it reacts with HCl. That is a solution. Yes, we don't bother. So magnesium displaces 1.008 gram of hydrogen when it reacts with HCl. That is especially 12 gram of magnesium. Then that shows what? Equivalent mass of the respective element. For example, equivalent mass of sodium is there, that is 11. So that means 11 gram of sodium are, right here. So listen, NaCl is there. Okay, so NaCl means if it dissociates, it gives Na plus and Cl minus, or if you have to take it in an atomic, Na and Cl. Correct? So students, here what happens when it dissociates, this NaCl dissociates means it gives how many moles of Cl. For example, 23 gram of sodium or 23 58.5 gram of NaCl displaces 23 gram of sodium and 35.5 gram of Cl. We just assume that plus minus right. So students, atomic mass is depends on number of protons, not number of electrons. So electron whether it is loose or not, we won't bother about that. Its atomic number always 23 only. So this is the answer. So here what we got 35.5 moles of what? Chlorine. So here what? The mass of element combines or displaces this much. 35.5 gram of chlorine means that is its equivalent mass. So this means what? 23 gram of sodium are equivalent mass of Na is 23. Why? Because after decomposition it displaces 35.5 gram of Cl minus. I hope you understood. So this is a reaction that shows the equivalent, that explains the equivalent mass of the respective element based on the displacement or a combination. So here what happens? This NaCl, this displaces 30.5 moles. The equivalent mass of Na is 23. If you want to write it in sentence, students, it was 23 gram of sodium as the can combine with 35.5 gram of Cl to form NaCl. Therefore, 23 gram is the equivalent weight of sodium. Okay, students. So this is the equivalent weight of the respective elements. Any doubts in this? This is atomic mass, that is molecular mass, and that one is equivalent mass. I hope you understood. So now we will go with the how to calculate molecular mass, how to calculate atomic mass in the particular. So students, you know atomic number and the atomic mass I told you is the mass of the element which is present in the atom. How to calculate? So for example, sodium is there, it is written in 1223 means 23 the atomic mass. Carbon is there, this is 612 means 12 is the atomic mass. If compounds are there, molecules are there, then how can we calculate the molecular mass? To do that, so listen, I will take a simple example. NaOH. Sodium is there, oxygen is there, hydrogen is there. How to calculate the mass of this means sum of all the atomic mass of the atoms present in a molecule gives the molecular mass. So here molecular mass is equal to sum of atomic masses of all the atoms in a molecule or a compound, whatever it is. Molecular mass I said means that is molecule. So here molecular mass of what? NaOH you want means Na is there, oxygen is there, hydrogen is there. Okay, so atomic mass of here. This is atomic mass of Na plus atomic mass of oxygen plus atomic mass of hydrogen. So atomic mass of Na is 23, oxygen is 60, hydrogen is 1. We will get 40. 23 plus 16 plus 1, that is 40. So the molecular mass of NaOH is 40. Okay. So similarly, next. For Na2SO4. Okay. Here the molecular mass of Na2SO4 is equal to 2 into Na plus 1 into sulfur plus 4 into oxygen. Then you add this 2 into 23 plus 1 into 32 plus 4 into 16. Okay, what is this NaS and that is the molecule atomic masses of the each atom. Okay, so this is 46 plus 32 plus 64. Okay, so if you add up this, 142 is the molecular mass of sodium sulfate in Na2SO4. Okay, so the next one is C6H12O6. That is what? Glucose. So molecular mass of C6H12O6 is 6 times of carbon plus 12 times of hydrogen plus 6 times of oxygen. That is 6 times into 12, 12 into 1 plus 6 into 16. This is 72 plus 12. And this one is 96. If you add up these students, you will get 180 gram. So 180 gram is the molecular mass of this C6H12O6. Okay. If you want to calculate this for ammonia, that is NH3 means 1 into nitrogen plus 3 into hydrogen. So 1 into 14 plus 3 into 1 will get 14 plus 3, that is equal to 17 gram is the molecular mass of NH3. You can calculate it for H2O also. That is 2 into hydrogen plus 1 into oxygen. That is 2 into 1 plus 1 into 16. So 2 plus 16, that is equal to 18. Okay. So another one is there, you can calculate it for HCl. 1 into hydrogen plus 1 into Cl. That is 1 into 1 plus 1 into 35.5. So that is 1 plus 35.5, that is equal to 36.5. The only way is, students, the addition of all the atomic masses of all the atoms which are involved in the molecule gives the molecular mass of the compound. I hope you understood this. What is molecular mass, what is molar concept, and everything. Okay. So the next one in this is the way to calculate molecular mass and also atomic mass. So I told you the atomic numbers are there. In the types are there. Isotopes and isobars. Okay, what it is? Isotopes and isobars. So what is isotopes mean, students? You know, the atoms having same atomic number but different mass number. Okay, the atoms having same atomic number, different mass number is called as what? Isotopes. So example for this is carbon, nitrogen. This is 7, 14, and carbon 6, 14. Similarly, isotopes means carbon 6, 12, carbon 6, 14. So here isotopes means the atoms having same atomic number, different mass number. Here students, atomic number for both carbon is 6, but mass number is 12 and 14. So if the atomic numbers are same, mass number is different, they are called as what? Isotope. Similarly, hydrogen 1 is there, hydrogen 1, 2 is there, hydrogen 1, 3 is there. There are 3 isotopes of hydrogens are there, and if we get the average atomic mass, we will get this one abundantly in the nature. So this is taken as a standard value of the hydrogen. So here 111 is the same atomic number, that is 1, but different mass number. Different mass number. Here mass number is 1, 2 and 3. Okay, so these are called as what? Isotopes. Then what are isobars? This is just opposite to this isotope. Means the atoms having same mass number, that is atomic mass, but different atomic number. So example for this is students, carbon 6, 14 and nitrogen 6, 14. Okay, similarly, argon 18, 40, calcium 20, 40. These are also isotopes. Here they have the same mass number 14, 14, 40, 40, but different atomic number. So the atoms having same mass number, different atomic numbers are called as what? Isobars. Okay, so this is isotopes and isobars, that is based on what? The number of based on the atomic number, that's what? A mass number. Okay, students. So the next topic for you is chemical combinations. That is now chemical combinations. Let's say 3 laws are there. Laws of chemical combinations. In that, first law is law of conservation of mass. Law of conservation of mass. Second, law of definite proportion. Third one is law of multiple proportion. Okay, students, Three laws are there. Law in the laws of chemical combination, laws of conservation of mass is there, law of definite proportion is there, law of multiple proportion is there. Then we will discuss one by one. What is law of conservation of mass? So I write the statement for students. Okay. It states that during chemical change, mass can neither be created nor be destroyed. Okay, so the statement of this law of conservation of mass is during chemical change, mass can neither be created nor be destroyed. So in the chemical reaction, students, mass is there, that mass, if the products are there, reactants are there, reaction taking place, then also the mass neither be created nor be destroyed. We cannot have extra mass we cannot remove the mass which is present in that. We just convert them from one nature of the compound to another nature of the compound. For example, I will say here, example is here, that is NaOH plus HCl gives rise to NaCl plus H2O. So students, here mass of NaOH is 23 plus 16 plus H, that is 40 gram. HCl is 1 plus 35.5, that is 36.5 gram. Okay, so here NaCl means Na means 23, Cl means 35.5, that is 58.5 gram. Here H2O means 2 plus 16, that is 18 gram. So what is this law of conservation of mass means? So listen, here this shows 40 gram of NaOH reacts with 36.5 gram of this HCl to give 58.5 gram of NaCl and 18 gram of water. So students, this NaOH is a base, this HCl is acid, this one is salt. Okay, here what happens? The base reacts with acid to form a salt. Okay, during chemical change I said, because the nature of the reactant and product is different. Acid and base react with each other to form what? Salt, that is a chemical change. But mass can neither be created nor be destroyed. That means, so here 40 gram is there, 36 gram is there. If you sum up the masses of these two reactants means, so 40 plus 36, that is 76.5 gram of reactants is equal to 76.5 gram of products. I hope you understood. Here the mass is also 76.5 in the product. The mass is 76.5. The only change takes place here what? The nature of this base reactant. So base is there, acid is there, changes to salt. Here when base and acid reacts with each other, changes to salt means the chemical nature change. But here mass cannot change. So this is called as what? The conservation of mass, the law of conservation of mass. So 76.5 gram of reactant gives 76.5 gram of products. Okay, I hope you get. So next, similarly, nitrogen is there, reacts with hydrogen, gives NH3. Here also students, So this is a gas, this is also gas, this is also gas. Nitrogen is different, hydrogen is different, and NH3 is different. Their chemical behavior changes. So here, this is 28 gram of nitrogen reacts with 6 gram of hydrogen gives 34 gram of, so 34 gram of this NH3. Okay, so here if you add 28 plus 6 means you get 34 gram. In product also 34 gram. So here two different gases are there combined with each other to form ammonia. Okay, this nature is different, hydrogen nature is different, ammonia nature is different. Of course, the chemical change takes place. But here what happens? 28 gram of nitrogen separately reacts with 6 gram of hydrogen, but they combine with each other to form a product of 34 gram. Here the reactant present is also 34 gram. Here the product is also 34 gram. Then law of conservation of mass satisfied. Now, conservation of mass satisfied. Not only this reaction, students, if you consider C plus O2 CO2, you may get the same answer. Okay? And another one, if you take, listen, I just said this is displacement reaction, this is combination reaction. I'll say now decomposition reaction. CaCO3 gives rise to CaO plus CO2. Correct? Ca means 40, carbon 12, this is 48, total 100 gram. So here Ca is 40 plus 16, that is 56, this is 12 plus 32, that is 44. This is 100 gram, 56 gram and 44 gram. So this is 100 gram reactant, students. Gives individually these two means that is 100 gram. Whether it is a displacement reaction, whether it is a combination reaction, whether it is a decomposition reaction, then also the law of conservation of mass obeys the reaction. So here 100 gram of reactant decomposes to give different proportion products, so that sum up of all the masses of those products also gives 100 gram of the reactant which is reacted with each other. So that is called as what? Law of conservation of mass. So this law is suggested by what? Dollar. So Leviezer. Okay. So Leviezer was the scientist who first suggested the chemical combination law, that is law of conservation of mass. You know about that energy is also there, law of conservation of energy. That means energy either be created nor be destroyed. For example, in light what we are using in our home, so we supply electrical energy. So that electrical energy came from what? Hydropower plants. Okay, so the water energy changes to what? Electrical energy. That electrical energy changes to light energy, and that light energy then passes for some other energy. So in universe, neither mass nor energy or anything else, neither be created nor be destroyed, but only thing is it can convert it from one form to another form, that is applied here, students. Okay, so this is all about the first law of conservation of chemical combination, that is law of conservation of mass, suggested by what? Leviezer. Okay, so for today, this class, this much is enough. In the tomorrow's class, we will study law of definite proportion, law of multiple proportion. So here, definite proportion means name it shows what? The compounds or reactants combined in a definite ratio. Here, multiple proportion is different ratio to give different products. So in the next class, I will explain the statement as well as the example with respect to these two laws. For today's class, this is enough. So students, in today's class, what you are going to remember, what you have to remember is how to calculate number of protons, neutrons and electrons, and how to calculate this conservation of mass. So This law shows about the balanced chemical reaction. Listen, N2 is there, H2 is there, that reacts with NH3 means the proportion cannot satisfy. So we have to take the balanced chemical reaction. Okay, so this is all about today's class. Tomorrow we will discuss these two laws. Thank you.